All right. Hi, everyone. I think I'm live. I'll start the Discord. Right. Okay. Hi, everyone. Can someone say something on Discord just to make sure that I'm actually broadcasting? All right. And can you hear me? Can people hear me? Okay. All right. Yes, great. Hi, everyone. So the Discord is going to stay up. I'm going to try to do the lecture while also looking at the Discord. We'll see how it goes. I think it depends on how many students we have in the room. So I'll just start my slides. So welcome. Welcome to the people who are starting first year early. Welcome to UofT. I am looking forward to seeing you in person soon. So like I announced on Piazza, I have booked a room for all of us to meet up for a lecture that's in person on Thursday. We'll see how it goes. We'll see how many people show up, how well it works, how well the online lecture works. And depending on that, we might adjust. I think probably most people know the UofT crest, which actually you don't see it because I'm there. But this is the EngSci crest, which people might not know about. So this was designed by Professor Deleterio, who's been teaching linear algebra recently, but I believe he's retired now. Those would be integrals, which you'll see pretty soon in your calculus class. And this is like the English letter N and the Greek letter psi. So we say EngSci, some people say EngSci. I think there's no agreement on that. And this is the logo that I made with DALI yesterday for this class. So there's like data sciencey stuff here and also like the letter T that kind of looks like a pencil. I hope you like it. So before we start, if you haven't installed our studio yet, your best bet is to go to posit.cloud and make an account there now. So the kind of stuff that I'm going to be talking about is, and I'll emphasize it again later, is really not a spectator sport. You can only learn it by practicing and by doing, so it's really important that you have things installed or at least make an account on the web app. It's about as good as having RStudio. So this course, I just had the idea of doing it like a week ago, so we'll see how it goes. So thanks for taking the ride with me. So I have several goals here. So my main goal is to introduce computational thinking. So I don't know about most, it varies year to year, but it's about kind of a 50-50 split between people who have programming experience and people who don't have programming experience coming into the engineering science program. And the goal of this course is to kind of give you skills that are not ESC 180. I'm not going to pre-teach ESC 180, but that kind of get you in the mindset of doing stuff that's like ESC 180. So I don't have kind of strong evidence that it would help, but I think it stands to reason that it would help you with ESC 180 if this is something that you're worried about. I also hope to just teach you a little bit of data science as kind of a bonus, or maybe you already know programming and you're mostly here for the data science. So in this case, I'll teach a little bit about how to use computers in order to analyze data. So to discover trends in past data, kind of realize, oh, like this happened because of that. Also predict future data. In this course, so data, of course, comes in many forms, right? So, in a way, kind of the whole of the internet is data. So text is data as well, images is data, videos is data. Here, we're going to be more focused on working with tabular data, meaning data that's set in tables, that's usually just numbers, sometimes kind of small pieces of text. So the kind of thing that you could put in an Excel spreadsheet. So a third goal for this course is to introduce what's called functional programming. So if you haven't had programming experience before, what I'm about to spend the next couple of minutes on is not supposed to make sense to you. This is more for the people here who do have programming experience to kind of preview what we're going to be talking about. So functional programming can mean actually a lot of things. So here I want to draw kind of the main distinction between what people would be used to probably if they had some programming experience versus what the kind of thing that I'm going to be doing. So if you think about having a list, like here is a list of numbers, like let's say 5, 6, 7, and you want another list that's the squares of those numbers. So like 25, 36, 49. So for sure, whatever you do, you kind of need to define what square means. So you need to somehow program into the computer that square of x is x times x. And you hope that the computer maybe doesn't know about squares, but definitely knows about times. This is actually true about modern computer hardware. The times operation is built in. You don't need to worry about it when you're writing software most of the time. Whereas the power operation is not necessarily defined. So you tell the computer that by square, you mean if you give me an x, the square is x times x. And then usually what most people who have programming experience, I think, would say, well, how do you do it? Well, maybe you start with an empty list and then you add 25 to it and then 36 and then 49. Or maybe you would say, well, I'll make a list that's like 3 something, like maybe 3 zeros or something, and then I'll change the first 0 to a 25, the second 0 to a 36, the third 0 to a 49, something like that. So in functional programming, of course, the end goal is the same, but you would approach it in a more kind of mathy way. So you would just say, okay, like you have the function square, and to get the squares of the elements of L, what you would do is you would use this map thing. So this is sometimes called a higher order function. And map is going to be a function that will take the function square and it would take whatever else you want to give it. And in particular, what map means is apply square to every element of L. So that's kind of the main distinction between what you are probably familiar with and functional style. So why, and kind of you might think, okay, well, like, but the computer has to do the imperative way. Well, yes. There had been in the past computers that were like more geared towards functional style, but yes, a modern computer would definitely have to do it. However, when you're programming in functional style, the idea is you don't think about it. You just tell it, I want map, you figure out how to do the map. So why do it? Well, for one, we're learning R, and functional style programming just runs faster in R. So many people also argue that writing programs as if they were algebra in this kind of way where you're not saying I'm going to build up the output bit by bit, but this is what the output is supposed to be, this is the formula for the output, leads to cleaner programs and fewer bugs. I think that's arguable, and I think a reasonable thing to say would be that some problems lend themselves naturally to functional style programming, and that includes the kind of stuff that we're going to be doing in this mini course. And some stuff maybe doesn't, but some people definitely say it. So another reason is just kind of practical for me. So I don't want to pre-teach ESC 180. That would be silly because not everyone can take this course. It's optional, and I don't want for some people to get ahead while some people are behind because they couldn't take this course. So I want to teach something that's kind of separate from ESC 180. And I also separately from that just want everyone to be starting from the same place. And in my experience teaching this kind of course, actually, usually I have people, some with prerequisites, some without, some with programming prerequisites, some without. And they pretty much all start from scratch, usually. So that's my theory of why this mini course might work. Again, it's an experiment. It might not work. We'll see how it goes. So what's data science? So this is like a famous thing from the Harvard Business Review. So that's like, I guess they have a print version as well, but it's like a website. And like I think about, so this would be October 2012. So they had like this data scientist, the sexiest job of the 21st century. And let me tell you, like when I first read it, it surprised me a lot because I've been like lying to people at parties and saying I'm a firefighter when I could be saying I'm a data scientist all along. But there was kind of, and there still is, a lot of excitement about the possibilities of data science. I have like a couple more memes here. This kind of claims that data science is kind of like at the intersection of computer science, meaning how do you get computers to solve problems for you, of mathematics. There is some math involved, which you'll see in ECE 286 maybe at first, and then in further courses down the road as well. And also domain expertise. So the consensus view is that you can't really just come in, be a data scientist, and just do something with data that's useful without really understanding the data first and understanding what's going on in the data. So that's kind of the idea, is data science is like a little bit of math, a little bit of computer science, and a little bit of the idea of, well, you got to actually figure out what's going on in the particular data set that you're thinking about. Here's one more that's kind of old. So a data scientist is a statistician who lives in San Francisco. So this, I guess, plays on the idea that a lot of jobs, especially kind of in tech, were just like used to be called like statistician or business analyst, and got rebranded to data science a little bit, like statistics on the Mac. So data scientists like Mac. Not me. I run Linux. A data scientist is someone who is better at statistics than any software engineer and better at software engineering than any statistician. I would say arguable, but it's kind of funny. And there was this post from Facebook, which I guess I didn't like, but I did take a screenshot. So I guess you guys would know more about that. All right, so specifically in this mini course, we're going to be focusing on, like I said, processing tabular data, so basically spreadsheets. We'll learn how to visualize tabular data in a kind of professional and nice looking way. And along the way, that also involves a fair amount of programming, so that works well, I think, in terms of learning both data science and learning computational thinking skills. And we'll start talking just a little bit about predictive modeling, so predicting future data from past data. So one thing that I worked on for actually like a couple of years of my life were spent on this. So you have like a hospital database where you have a lot of data about past patients. So you have, whatever the demographic characteristics, so like how old they are and stuff. You have the results of all the tests that were run, everything. And then what you might be interested in is if you have a new patient and you have some data about them, so you have the demographics and you have maybe some test results, you want to predict the outcome for that patient. For one, because you might like to change that outcome, right? So one thing that I worked on was building an early warning system in the hospital where you would automatically look at what's going on with the current patient so far. And because you have all this data on past patients and what happened with them, you can make a prediction, this patient is maybe going to deteriorate, and the hope is that you'll then send a notification to the doctors and the nurses who are treating the current patient, and they'll hopefully change that outcome by intervening earlier. Or you might be building something like Zillow, if you're familiar with the website. So that's a website for like real estate. And the idea is you give it past data about houses and sale prices. So you say this is where the house is approximately, this is the square footage, whatever else. And then you might like to try to kind of figure out what's the best price to set for this house so that it will sell at the best price possible, or something like that. Or on the other end, you might say, what is a reasonable offer for that house based on past data of how houses that are similar to this one were doing on the market. So that's the kind of thing that you might do with predictive modeling. So a little bit about just the logistics of this course. So in general, in EngSci, if you're new, you don't know, but you will. There's a fair amount of support actually for first-year students. So there's office hours, of course. I will have some office hours as well, but there's TA help. The TAs grade your homework, they grade your exams. Like a lot of it is just you get your grades, but some of it is you actually get help and feedback. And unfortunately, this summer, like I just had this idea very recently. I was not able to get a budget to hire any TAs, so it's just me and you in here. So we'll try to make do as best we can. And kind of, in a way, you get what you pay for. So basically, the way I wanted to run it is there's going to be lectures and there's going to be homework. And the homework is going to be mostly automatically graded. So I have some fancy ideas of like making you interact with ChatGPT and sending me like the transcript of how you interacted with ChatGPT. And if ChatGPT said, okay, like you're doing okay, then I'll know that you're probably doing okay. So obviously, you can kind of try to fool ChatGPT, so I'm working on ways to make it so that if ChatGPT says that you're doing fine, then you're actually doing fine. We are also just, you can automatically run some of your programs, so you'll see that later this week around Friday or Saturday. So I want to emphasize again, like programming, data science, those are not spectator sports. So in the same way that you can't learn to kind of whatever your experience is, like riding a bike or swimming or playing the piano, like those are the kinds of things that you really cannot learn by watching other people talk about them or even watching other people do them, right? So I can give you maybe an excellent lecture about how to ride a bike. It's not actually going to help you unless you actually ride a bike. So I urge you, if you want to take up this opportunity, to actually do the exercises. And some of it I'm going to enforce because I'm going to kind of automatically grade some of the homeworks. But a lot of it, like at the end of the day, you're not getting a grade from me. So usually grades are an incentive, but I hope, especially for the first years, that you still are kind of full of energy and enthusiasm and are going to do the homework just because you want to. If you don't like homework, EngSci is probably not the right choice for you. So the plan for this week is I'm going to start introducing the R programming language. So I'm going to go to Discord now for 5 minutes and see if I can answer anything. And then we're going to switch to our studio and start coding. I've booked a room on campus, SF 1105, for 7:30 on Thursday. Completely optional. I'm still going to stream the lecture just from that lecture hall. But if you want to come down to campus, just check out the room, whatever, just hang out, you're welcome to. And I'll see how everything goes. I'm not sure. This is the first time I'm trying to do this. So around Friday, maybe Saturday, I'll give you kind of more of a plan for the next 3-4 weeks for this course, depending on how things go. So that's the end of the slides. So if you made an account on posit.cloud, then what you want to do is you want to log in, then say new project, and then say new RStudio project. So yeah, so one of the advantages of having RStudio installed on your computer is you don't have to wait this long. But here it is. And then you press the plus here, and you want to start a new R script. So I'll go to Discord now. We'll take a bit of a break, and I'll start talking again at 8:02, I guess. So our ChatGPT code's good. Well, like, there are not all of them, but they're not all good. However, I gotta say, especially for beginner students, they're probably better than you can do. So yes, I think we're just doing like a discussion, not really questions. So like I said, we're waiting until 8:02. Should you start a new directory? It doesn't really matter for this for this week, but sure, why not? So I would start kind of a new file, and then I would save it. So here I have my DS101, and here I'll save. So I already saved my lecture1.r, but yeah. If you use VS Code, so I use VS Code to code in R now, but I just find that it's like a little bit finicky. So if you're just a beginner, I would probably not recommend VS Code. If you've used VS Code before, then sure, like use VS Code, install Copilot, it's all good. Yeah, so like some problems might arise, but it should honestly be fine. I run VS Code without problems. No, I don't think you would be confused. So, I mean, it might be good if you start working with VS Code just because, with RStudio, sorry, just because, like, why not? And I will be doing some stuff that's a little bit specific to RStudio. So yeah. So honestly, so like I use VS Code now for everything that I do, but I think it has a lot of advantages. So in ESC 190, I definitely will encourage people to use VS Code. In ESC 180, I'm still considering whether I should switch to VS Code or not. But for beginners, it can be like it's a little bit finicky, where like you might be in a situation where it doesn't work and you don't know why, and this doesn't happen with RStudio. So which ID is used in ESC 180? So I have not 100% decided yet. So we used, traditionally I used Paizo, so I just spelled it in the chat. I like Paizo a lot. I think I'm the only one, but I think it genuinely does have some advantages. VS Code also has some advantages, so I'm thinking about that. Yeah, so I guess I have 1 more minute. So this will not necessarily be super useful for the people who are just starting out, but uh, just for people who are interested. So the reason I like Piezo is that, and this would not be comprehensible to people who are just starting out, so you can rewatch this recording in December or something, or I guess November. So what I like about Piezo is this kind of thing, where you can do something like this. So here I'm putting a breakpoint here. I'm at plus. So I'm running it now, and now I can step in. So now I'm on line 2, and so you can, of course, do it everywhere. It's just a lot more convenient in Piezo. So here I can ask, okay, like what's the value of x? And then I can say, oh, like what about x times 2? And I can have it right here. I can execute whatever I want here. Then I can step to line 3. And now I can query what's x. And then I can highlight this, for example. And I want to say, okay, I want to know what y is about to be. And here I just highlighted it and pressed Alt-Enter, and it computed the 7. So of course you can do it in any IDE. It's just that in Piezo it's a lot easier to do. And I think you can be very effective at debugging Python this way. Piezo, so VS Code, this kind of thing is not as convenient in it, which I think is unfortunate. Maybe they'll fix it. Piezo has its downsides as well. So, okay, all right. So, yes. So, okay, all right. Is that the Python shell? Yeah, well, so this is what's called a REPL loop. So it's not quite a shell, but it's like almost a shell. So, okay. So, all right, okay. So I'm going to start talking about R. So just as a warning to people who do have experience programming, this is going to be a little bit slow for you probably, which is how it should be. So, okay. So talking about shells, so this down below is called the R shell. So here I can basically do something that's kind of like a calculator. So I can say, for example, 42 plus 3, and it'll tell me, oh, that's 45. So I can just type it in here. I can also have more complicated arithmetic expressions. So unlike with kind of the cheapest calculator you can get, you can have not just numbers, but text here as well. So I can say, for example, what's the value of hello? And the answer as well, the value of hello is hello in the same way that the value of 42 plus 3 is 45. So in Python, you can actually operate on those things. In R, not as much. But basically here, I can enter anything arithmetic. I can also enter text. And R is just going to say, OK, the value of this is 45. The value of this, for example, is hello. OK. So we could have more complicated stuff. So we can have something like 45 minus 43 or something. And then we can raise it to the power of 3. So this means raised to the power. And this is, of course, 2. So 2 to the power of 3 is 8. So this is a more interesting situation here because in order to compute it, you need to first compute 45 minus 43, and then you can raise it to the power of 3. So far we had just arithmetic expressions. We had text. So in R, this is referred to as character. So it's a little bit kind of not the same as some other programming languages. So in R, this is a character. You can also have what's called logical values. So those would be true and false. So just like 42 plus 3 is equal to 45, you can evaluate something like this. So you can say 2 plus 1 equals 3. So note here that I used two equal signs. So this is not the same as, well, this is a little bit like what you've seen in high school math. So this is an expression. And the idea is that this expression, well, it's either true that 2 plus 1 is equal to 3, or it's not true that 2 plus 1 is equal to 3. So as you hopefully know by now, it is true. So if you give something like this to R, in the same way that R can compute this, R can compute this. And the way it does it is it says, OK, I'll compute the left-hand side. That's 3. The right-hand side, don't need to compute anything. It's already 3. And then if those are equal, then it's going to be true. So we can try to change it up, and we can say, like, is 2 plus 1 equal to 5? And the answer is, well, no. So this means that the value of this expression is false. So again, like, it's nothing complicated. It's just in the same way that you can compute a value here. If you have this two equal sign thing, then that is either the expression is true or the expression is false, because you're comparing the left-hand side to the right-hand side. So you can also do it with other stuff. So you can say, like, is 2 to the 10 greater than greater than 10 to the 3. And the answer is yes, it is. So the reason I chose this is because this fact is actually going to turn out to be very useful in ESC 180, ESC 190. In general, you can kind of remember that 2 to the 10, so that's 1024, is about equal to 1000. So this is a little bit of an aside, but you'll see later that it's useful to know. So for example, if you want to know what is like 2 to the power of 30, the answer is that is equal to, just because of how math works, right? So that's equal to 2 to the power of 10, again to the power of 3. And because this is slightly larger, but not that much larger, this is approximately equal to 1000 to the power of 3. So that would be 1 times. So I'll write it. So R would not understand this times thing, but I'll just write it as 10 to the power of 9. So later on in ESC 190, you'll see why this fact is actually quite useful. For now, this is just an example. And again, like, we can do, like, is it greater or equal? Well, yes, it's also greater or equal, because if it's greater, then it's also greater or equal. We can ask, is it smaller? And the answer would be false. So, OK. So far what we've been doing is basically using R as a calculator, and you see that you can do a little bit more than you can do with a calculator, because you can have text, and text can also have a value, and you can also have expression with comparisons or with greater, equal, stuff like that, and that would also have a value. So later on, it's going to be a key distinction between just this having a value and actually telling R print something. So in order to tell R to print something, I'm doing this. So the distinction here, like it's going to show up either way here, but the distinction is here, this indicates that it's just telling you what the value here is. This is actually an instruction to R, just print this to the screen. So for now, the distinction is going to be a little bit opaque, but it'll become important later on. So if you want to print several things, so you can say I am aiming for, I guess, A, and what you're aiming for, 97. And what that will do is it will just print this, and then it will print this, and then it will print this. So good luck to you, but that technically works. Okay. So now what we'll do is something, again, that's kind of similar to what you've seen in math, but slightly different. So what you can do is you can define variables. So basically, so kind of boxes that store values. So I can say, for example, x is, let's say, 97, and let's say that we have an EngSci adjustment. And the EngSci adjustment itself is, I don't actually know what it is. If you ask me in September, I will be able to tell you because I'm analyzing some data now. But let's say that the EngSci adjustment is like a -12. That's probably optimistic. So now what's going to happen is here I'm saying put -12 into this thing, into this box that I'm calling EngSci adjustment. And now I'm saying compute this. So this would be 97 plus 12 because EngSci adjustment, plus -12, sorry, because EngSci adjustment is -12. And then whatever this is, so this would be an 85, that's going to go into x. So I can run this. So this did not display anything, and this was because I'm not really computing a value. I'm just saying take -12 and put it in EngSci adjustment. And now I can run this. And what I'm saying is compute this, so 97 plus EngSci adjustment, and put it into x. So now I want to point out some things in RStudio and also kind of tell you a little bit about how to find your way around it. So you'll notice that every time I say something like this, so if I say put 5 into A, I have a table here which keeps track of all my variables. So the value of A is 5, the value of EngSci adjustment was defined before as -12, and so on. So when you're doing something like this, you can keep track. So the other thing is just technical. So in R, unlike in other programming languages, the good style is considered to be using this arrow. I think there is something to be said for it. It's kind of intuitive. So like it literally says like take -12 and stick it in EngSci adjustment. It's a little bit annoying to type if you don't know how. So in order to type this, you would press the Alt key, and then you would press the - key. And that would give you the arrow. So in fact, as you can see, it's extremely easy to type in arrows. So another thing is I kind of switched to writing some stuff here. So I can run, so what I was doing before is I just copy and pasted this. I can actually do it automatically. So if I press Control Enter, to run the line. So I can run it like this, I can run it like this. So in here, I can give the instruction to print what x is. So here, it's 85. I could also just type in x here, and it'll tell me, okay, the value of x is 85. Similarly, if I have an x here and I say Control Enter, that will also display an 85. There is a bit of a distinction. So apart from the fact that here it just displays the 85, here it says 1, and then it says 85. That we'll see later on. So keep in mind that there is cat and there is x, and those are not exactly the same. For now, it shouldn't really make a lot of sense. So you'll notice also here that some of the text here is displayed as green. So that's because if you so anything that goes after the pound sign is considered a comment. And R just ignores comments. So those are for human readers of the code. So I have a bit of a pet peeve. Do not call it hashtag. Hashtag is a thing on Twitter. I guess now X is what it's called. And it's like hashtag. So this thing is just the hash or the pound sign. It's not by itself a hashtag. Okay, just it's fine if you want to call it hashtag, but you shouldn't. All right, I'll switch to Discord for a while to see if there's any questions. So what's the difference between a equals 1 and a arrow 1? The answer is, for all practical purposes, there isn't a difference. If you want to use equals, you can. In some very constrained situations, which we won't see in this mini course, only the equal sign makes sense, and this doesn't make sense. So if you know a little bit about it, so you can look up default arguments and see how those things work with equal signs and arrows. But basically, for now, it's the same. So some people kind of consider it like really bad manners to use the equal sign in R. To be honest, like you can, it doesn't hurt anyone. Use a Mac. Oh, yeah. Okay, yeah. Thanks for the answer. Is it EngSci edge variable? Yes. So anything here. So here I said like, so whatever I put in values. So here I put in, for example, this into x. So x is referred to as a variable. Is R object-oriented? So object-oriented can mean two things. So it might mean you have to code in object-oriented style, which you clearly don't. On the other hand, it can mean you can code in object-oriented style, which if you really want to, you can in R. Okay, so I want to, so we haven't done a lot, but I still want to stop and ask you to do a bit of an exercise. And if you're stuck, kind of ask questions on Discord, stuff like that. Here's the task. The quadratic equation goes like this, right? So ax squared plus bx plus c equals 0. And what I want you to do is compute the discriminant. So the discriminant, if you remember, is b squared minus 4ac. So in R, of course, you have to write 4 times a times c. Store it as a variable. And then store true in no roots if ax squared plus bc has no roots. So this would be the situation if the discriminant is smaller than 0. So some of you with background might be tempted to use something called an if statement. We haven't done it yet. You don't need to use it. So just try to figure out how to do this exercise. All right, so I'll give you a couple of minutes and I'll look at questions on Discord. Please don't post the answer. So to run the whole file, you can press source and you can press so you can press source. How do you input an R? So like it's very rare that you would input an R, to be honest. So ABC, so you should like when you run it, you should just say like A is 1 and then B is 2 and C is 1 or something. So that does have one root, right? So I'm just pasting that here. To be honest, like I've never used input in R. It just makes no sense. Like if you want inputs, you probably don't want to run it in R. So usually what you do is like you read from a file if you want to kind of deal with input. However, you can Google it. I'm sure that exists. So R is a lot like Python in the sense that it's not usually compiled. Kind of the distinction between so the thing to understand about kind of compiled language or not is any language can be compiled if you really want to, right? So nothing's stopping you from compiling whatever you want, or almost. It's just a question of kind of what's usually done. So R is just used for data analysis, and really kind of it's convenient for that. For anything else, it's not super convenient. No, so I said like Python in the sense that it is not compiled. Can you compile eval in Python? Well, I mean, sure. It's just that like you might need to compile while you're running the code again, but why not? So why sometimes we write at the top, sometimes we write at the bottom. So in principle, when we write larger programs, we would run things kind of line by line from top to bottom. For now, I'm just scribbling things, so like just wherever I see space. So when it's a larger program, like it would be executed like line 1, line 2, line 3, line 4, and so on. How to run an R program in the terminal. So I mean, I guess it depends on what kind of terminal you are running. So in principle, so R is kind of R. So you can just say R and then you say run this file. So that's possible. So I'm just answering the question. It's not really. So that should be okay. Oh, I guess I need Yeah, well, so not quite, because I need like an optional thing. Yeah, I think it's RCMD. No, okay, I guess I don't remember. Yeah, so it's like that. So here it printed the high. So there's a question of like, what does the terminal do? I think that's like a longer story that we can't really get into. So it's a way to run software on your computer. All right. So, okay, so let's say that we have this. So the idea is basically like this. So if I have my A and B and C, so if I run this, now I have A is 1, B is 2, C is 1. So now I can compute the discriminant. So this would be B squared minus 4 times A times C. So if I run this, here the discriminant is 0. And now I want to compute no roots. And the way to do it is to just say, well, when does this equation have no roots? Well, it's when discriminant is smaller than 0. So I'll just do it like this, right? So discriminant is smaller than 0 is going to be false if discriminant is not smaller than 0, and it's going to be true if discriminant is smaller than 0. So currently discriminant is 0, so 0 is not smaller than 0. So that means that in this situation, the value of no roots is going to be false. And that's because x squared plus 2x plus 1 does have a root specifically, minus 1, right? On the other hand, we can come up with an equation where there really are no roots. So what we want is we want for 4AC to be large and negative. So I can make B be, for example, minus 2. So now I need to rerun this. So A is 1, A stayed 1. Now B has become minus 2. C stayed 1 because I just said take 1, put it into C. So now the discriminant is, that really should not, oh, because it's B. Yeah, I don't want this. I want this. So now I made the discriminant be large. I actually want it to be small. So now the discriminant is minus 96. So now the discriminant is smaller than 0. So when I run line 28, no roots is now true. So again, kind of just because I change this doesn't change anything, because this is just a program. A program is just a bunch of lines. So if I run those lines again, so again I run, put 1 into A, put 2 into B, nothing changed. Now put 10 into C, so now C is new, C is now 10. And now put B squared minus 4AC, so that's now going to be a different value because I changed C. So now discriminant is minus 36. So it's still the case that minus 36 is smaller than 0, so no roots would still be true. Okay. So we kind of almost wrote a little program that does something, right? So we told it what the coefficients are, and it computed no roots. Now, usually you wouldn't do it in R, but just for a start I will. So I'll just take this and I'll copy it into a new program. So a program in R is referred to as a script. So a program is just a series of instructions. And here we have a little program, right? So we can set A and B and C to whatever we want. And then when you get to the last thing, it'll print true or false depending on whether ax squared plus bx plus c has roots or no. So here we say no roots is true, right? And then you can change it and you can run it again. Like I mentioned before, if you want to run the entire thing, you can press source. And now this is false. So you can make b be really large so that you're sure that there are roots. So now there are roots. So I can run the entire thing and it will tell me false or true depending on what no roots is. So we did something useful here. I'll switch to Discord for a second. So can our programs be only run line-wise? Well, so our programs, whether implicitly or explicitly, are going to be run line by line. You can, for example, press source, which is going to run the entire thing. But running the entire thing means running things line by line, just without you pressing a button for that every time. So to run only specific lines, you can press Control-Enter. So didn't change anything. So here I'm pressing Control-Enter, 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 Control-Enter. So spell it out. All right. So, okay. All right. So that was that. So we for now, so we haven't needed it so far, but now I want to do something called conditionals. And what that means is we want to do different things depending on the value of some prior computation. So for example, let's say that I want to print the absolute value of n. And n could be positive and n could be negative. So for example, if n is minus 25, I want to print 25 without the minus. If n is 25 without the minus, I still want to print 25. Right? So here's how I can do it. So I'll write it and then I'll explain it. So what I'm saying here is I want to do either what's on line 8 or what's on line 10, depending on whether whatever I put here is true or false. So I'm saying if whatever's here is true, then I'll do this. If whatever's here is false, then I'll do this. And you can see that this does compute the absolute value, right? So that is because I'm saying if n is positive, just output n. And I'm saying if it's not positive, then output minus n. So if the value is not positive and I output minus n, that means I output the positive version. So if n, for example, is 25, then what's going to happen is that this will print 25 because it'll check, is this greater than 0 or equal? The answer is no, so that means we need to do this. Yeah, okay. Oh, there's people answering. Thanks very much. Okay, so let's do another example. So let's say that we have a variable and we'll name it like exam grade. What are you guys used to? 96. And then I'll say, like, if the exam grade is greater or equal than 95, I'll print hooray. And if it's not, I'll print alas. Something like this. So again, it's the same kind of deal, right? So we are saying, is this true? If it's true, then we'll run this. If it's not true, then we'll run this. So this will print hooray. If I change it to, for example, something terrible, like a 94, then it will print alas, right? So exactly the same kind of principle. So you can have kind of gradations here that are not just this or that. The way you can do it is, instead of just having like, if this is true, then do this. If otherwise, do this. You can say, if this is true, do this. And then you can say, okay, if not, then I'll check something else. So I'll say, if exam grade is greater or equal than 94, then I'll say, okay. And then the else I keep. So that's going to be like this. And now the way we're going to do it is we're going to check this. And if this checks out, so if this is true, we'll just do this and nothing else. If this doesn't check out, then we'll check this. And if this is true, then we'll do this and we're done. If this wasn't true and this wasn't true, then we go here and we print alas. Okay, so here, this is going to print OK. So two things to notice here, and especially if you're starting out, it will take some getting used to. So unlike when you're just writing on paper, R only understands things in the specific format that it expects. So in particular, that means that everything here is mandatory. So those have to be round parentheses. This has to be something that's true or false. Those have to be curly braces. Those have to be quotes, and so on. Okay. So if you just follow the format, so for now you can just copy and paste this. I guess I'll copy and paste this into Discord to make it a little bit more convenient for you. So yeah, why is the output cat in R? So to be honest, like there was a good, there is a good story about it, but I forgot it. But I'm sure if you Google it, it'll say. There's a question of what does cat do? So cat is just saying print whatever is the value to the screen. So if I say cat 123, it'll just print 123. How do you show only the objects in your current file? So Matthew W, you're actually asking several questions. So how do you show only the objects in your current file? You can't. Basically, whatever you run here is gonna be in here. It's not that the objects are in your file, it's that you've run them. So when I press Control Enter, it's as if I just copied this to the shell and executed it. So that's got to be global. It's not because it's in the one file. It could be two different files and still be global. Variables that are inside functions, which we haven't done yet, would not be global. So that's a separate question that you're also asking. So that would be if they're in a function. Your first question is you basically can't. How do you make multiple lines of code into a comment? I think you kind of have to do it line by line. Now, what you can do is if you want to comment the entire thing, what you can do is, apparently not. So there is a keyboard shortcut for in RStudio, which I don't use anymore, so I don't remember to put a pound sign in front of every comment all at once. So Control-Shift-C. So you can still do it kind of very fast. Okay. There's no Quercus page for this course. Yes, that's right. So there's just Piazza, and there's going to be a website, but it's not in Quercus. Are there different types of variable definition in R? So you can, if you like, force something to be a constant. Certainly different objects have different types, like integers and characters and stuff like that. Yeah, so if you fill out the form, I'll add your email to the Piazza. I also have a public webpage up after this lecture. So, okay. Yeah, so like if you're in Discord, you presumably have all the information you need, because how else would you be on Discord? Okay, so the last thing I want to talk about today is functions. So this is something that you saw on the slides before, and some functions you would be familiar with the concept just from math. So for example, you might like to say something like abs minus 5 for the absolute value of minus 5. And the way it would work is you send it the value minus 5, and then the value of the absolute value of minus 5 is going to be 5. Okay, so I'll define the function that we talked about before, so square. And again, kind of everything here is mandatory. So this is just the R way of doing what you would do in math, which is you would say square of x is equal to x squared, right? So like in math, you would define a function like that. Ordinarily in math, a function would be just like one letter, like f or g or h or something. But in R, usually it's more than one letter. It's better because so in math, part of the reason that you have like functions like f and g and h is one, some of the functions are not doing much. They don't mean anything, so can't really come up with a meaningful name for them. The other reason is traditionally you would write them on paper, and that would be like difficult. Now that you're typing stuff, it's really not difficult. So in R, as much as possible, we try to have meaningful names. So here what we're saying is, so this square corresponds to this square, and then we're saying this. So one way to read it is this is just the R way of saying this, that we're defining the function square, and what square does is square of x is x squared. Another way of looking at it is actually what we're doing is we're saying this is the function. So this is like x squared in math. And then we're saying take that and put it into square. So square is a variable which happens to store a function. Okay. So now that we've defined it, we can use it. So I can say, for example, square of minus 2. And once I've defined it, so now I have my function square over here. And that's the value of square. I can say square, not square root, sorry, of minus 2. And the value would be 4. How does R do it? Well, we told R what square is. And then we just do substitution, right? So we substitute minus 2 into x, and then whatever is here is the value of the entire expression. So it's just like math, right? So one thing to notice here is just like in math, right? So saying something like f of z is z minus 2 is the same as saying like h of y is y minus 2, right? So h and f are the same. And that's because this, you just substitute whatever you send in, right? So it doesn't matter if you called it z or if you called it y, as long as you're consistent about using this x in here, you can change x to be whatever you want. So people sometimes say that x is like a dummy variable. So that's informally. So formally, x is a parameter of the function square. So this is one. This is one example. So let me do another example. So let's say I want to define the function myAbs, not like myAbs, which I don't have, but I want it to be a function. And now what I want to do is I want to say, okay, I want for this function to compute the absolute value of x. How to do it? Well, we already know, right? So you can say if x is greater than 0, then the value should just be x, because the absolute value of x, if x is positive or 0, is just x. If x is greater or equal to 0 is not true, then the value is minus x. So when you're doing something like abs of myAbs of minus 5, what happens? Well, what happens is you're sending the minus 5 to x. So then the value of this is this, because you're just substituting 5 into x, right? What's the value of this? Well, the value of, so this is minus 5, and it is 5, but really I mean minus 5, right, or minus x. So what's the value of this? Well, this is false, so that means that the value of this is 5. And minus 5 is just 5. So the value is 5. So that is the process that R uses, right? So you send the minus 5 to x. So if you don't change x, which you really shouldn't, then what's going to happen is it's as if we just substituted minus 5 into this formula. And this formula is just like this. So you substituted minus 5 into the x. So now it's this. And the value of this formula, so some of you might have seen this kind of thing in math. So people write it with like the big curly brace, right? The value of this is, well, because this is false, the value is this, and this one just gets ignored. So that means that the value of this is this, and then the value of minus 5 is just 5. So we can verify. So here I defined myAbs, which again do not actually exist. And now the value of this is 5. So what we've done here is just kind of messed around a little bit. So again, if I want to write a program which outputs whatever is the absolute value of whatever I want, I of course didn't have to write myAbs because Python already has abs that's defined without me needing to do it. But I could define it, and now I could say like z is whatever I want, like minus 42. And then I can say I want to print my abs of z. And now if I run it, that is going to print 42. If I run it on like 53, that is going to print 53. So again, just like with the discriminant, we wrote a little program here which does something kind of useful, right? So you can input whatever number you want, and it'll print the absolute value for you if you run it. Again, to run the whole thing, you just press source. All right, I'm going to switch to Discord now. Could we do x is minus? Yeah, you can set -2 into x. And like I encourage people to just like anytime the question is can you do it, you can just try it and see if R yells at you. If it doesn't, then I guess you can do it. So I prefer, so you can say return. I prefer to write it without a return, and that's part of kind of emphasizing the idea that it's kind of functional and it's like math, right? So this is, you can think of it as a formula. Now, in Python, usually, it would be like, it wouldn't be unusual to say, oh, I want x to be 2x. And you're allowed to do it in R as well, like you can do it. That kind of breaks the idea that this is just a formula, because now you can't just substitute x, because x used to be something, and now here you're saying, oh, I want x to be something new. I want it to be twice what it used to be. So this is very usual in Python. The way I'm going to be writing R is just by avoiding that. So I'm never going to change the value of a variable to something new once I've set it. And that's kind of what you're used to from high school algebra, right? You never say like, oh, like x used to be 5, I now want x to be 2x. That just makes no sense in math. So the advantage here is that if you write it like that, then it kind of is just math. Not using return just emphasizes this point that it's not like so if you're familiar with returns, if you're not, just ignore what I'm saying. If you're familiar with returns, kind of when you say return, it means like you exit the function right away, stuff like that, right? So here, the way we're writing it is we never change the value of a variable. We're just substituting whatever is here into the formula. So return kind of makes no sense. You can, of course, still say return x. So you have to do it like that. This would be the same, just to emphasize the point that we're just substituting stuff into formulas. I omit the return, which you're allowed to do in R. And again, kind of another way of thinking about it is I want to be able to think of functions as just substituting in -5, and then I have this expression which it looks a little bit like not a formula. It really is a formula in the same way that like discriminant is b squared minus 4ac is a formula. This is a formula. This is saying if it's greater or equal than 0, then it's the same. If not, then the answer is minus that. But it's a formula. It's all right. Yeah. Can you use the same variable names inside and outside the function in R? The answer is yes, you can. If you're familiar with other programming languages, it works the same way in R. But we're not going to get into it today. So I'll stick around for a couple of minutes. Again, I want to emphasize this is not a spectator sport. If you don't practice what I've done in lecture, you are unlikely to benefit a lot from the lecture. So what I would encourage people to do is to just do the examples that I did in lecture from scratch. And kind of it's a lot to take in, so maybe you need to peek at your notes. But eventually, what I hope is that at least kind of in July, August, I realize that it's maybe too much to hope for in September. What I hope is for people to kind of go over the lectures and make sure that they can do every exercise that we did in lecture, every example that we did in lecture from scratch eventually. And I think ideally this is how it would always work. I know that kind of during the semester, or you'll find out that during the semester it's not always how it works, unfortunately. But during July, August, I really encourage you to kind of keep up and actually actively do the examples. All right. Well, I'll stick around until, I guess, 9. If you have questions, happy to answer. Otherwise, thank you. And again, so we are going to be on campus in person as well as on YouTube on Thursday at 7:30 p.m. Error, unexpected. So you should put the cursor in line 7. What are some built-in functions in R that are helpful? Cat is a function. It's a little bit a weird function because it has a job rather than computing a value. It actually puts stuff on the screen, so that's a useful function. Otherwise, a lot of the lectures later on are going to be about functions that process tables. So for example, just as a preview if you like, so I'll load a table. So the table that I wanted to load is called Gapminder. So the first time it's not going to work for you, so you have to say install packages Gapminder the first time. So it's already installed for me, so that's not going to do anything. So now I have Gapminder, the variable, in my workspace, and I can look at the table. So this is just like a table for life expectancy, stuff like that. So one thing I might like to do is maybe I want like a smaller table that's just for Europe for the year 1952. So there is a function for that, for taking a big table and just picking out the rows that I want. That function is called filter. So again, like this is just a preview, so you need library deployer, and then you would need to install it if it's not installed. Once you have it installed, you can run the function filter, and it can say, for example, continent is equal to Europe. And filter is a function that operates on tables. So the technical term for that in R is data frames. Again, this is just a preview. I'm not really doing a full explanation here. And that would give you a new data frame which just has the rows that correspond to European countries. And we're actually going to do a whole lot of lectures just about using those kinds of functions to operate on data frames. Is cat the same as print? Basically, again, kind of really, we're just using cat for the sake of the examples in the first couple of lectures. Later on, all the output is going to be like reading tables from the hard drive and then writing tables to hard drive. You don't really use that in R, but yeah, it's basically similar. Yeah. What is the difference between triple equal sign? I was not aware that there is a triple equal sign in R, so I don't know. To open Gapminder, so you need to first install the package. So you need to say install packages and then say gapminder like this. So that you just run the once, and then once that's installed, you say library gapminder in order to load the gapminder object. So like this, copy this into Discord. So MathEW. So it's not. So it's true that it's an index. It's not actually technically a list. It's technically a vector. So in R, everything is a vector. It's just that some things are vectors of size 1. So, and that's just how R works, is everything is a vector. Some things are vectors of size 1. Vector-oriented. Yeah, I suppose. So one thing, so in ESC 103, you will be working in MATLAB. And similarly to how in R everything is a vector, in MATLAB everything is a matrix. And I guess it makes sense because MATLAB does stand for Matrix Laboratory. What is the application of vectors in R? Well, I mean, like a vector, like you said, it's kind of, well, so like the distinction between vector and list is like a vector is a bunch of objects that are the same type, so kind of a bunch of integers, a bunch of characters, things like that, but like all homogeneous. So any time that you have a bunch of things that are all the same type, it's convenient to store them in a vector. But we'll see it later on. Yeah, so R is kind of, well, so kind of like, so for people, so I'll kind of answer the question about R, and this is more for people who are familiar with other programming languages. So kind of what is R good for? So this is kind of a good example of what it's good for. So in other languages, you could not say continent equals Europe, right? And the reason you couldn't is that continent, like, it's not a variable. Continent is the name of a column in Gapminder. That's it. So other programming languages would not know how to deal with it. R understands this as a formula. So it doesn't try right away to go and see, oh, what's continent? Never heard of that, which it wouldn't, because like it's just the name of the column. So this kind of style is possible in R, not so much in Python and MATLAB. And that turns out to be really useful for processing basically spreadsheets, where this kind of thing comes up a lot. So that's kind of the big advantage of R, along with the fact that there's a bunch of stuff for processing tables and for visualization that's really well supported around R, but could have been built for any other language as well. So you need to do library dplyr as well. So this is called a pipe. So again, this was just a preview. So I'm gonna do it in a more organized way, kind of before 9 p.m. on some day that's not today. But just as a preview, so you can have, so basically this is just this, I guess, is what I wrote. So this is just another way of writing this. So those are just the same. So this is just shorthand for this. So it turns out that this is useful if you want to do multiple transformations. So if you want to do, for example, one filter and then another filter, so maybe you want to say like year is greater or equal than 1970 or something. So here this is saying make me a smaller table, and this is saying like pick out just the rows with a year greater or equal than 1970. This is not the only way to do it, but this is kind of a convenient way to write it. You could, of course, also write it like this. It's just that that's more annoying to write and more annoying to read. So to type in this would be shift. Yeah. So Dippler, so people say Dippler usually. So this is kind of a collection of functions that are useful for processing data frames. Data frames are tables. All right. Thanks very much. Have a good night, or whatever time of day it is. Like if you're still in China, which I think some of you are, have a good day. I think there is it's like a 12-hour difference between Toronto and Beijing, I believe. Yeah, I will see you on Thursday. Bye. What is the union object in Dippler? I don't know. Thank you. Bye. Thanks. Thanks. Bye. Yes, I know that there was a problem with study permits last year, unfortunately, and some people actually arrived late. So there was some kind of accommodation. I hope it's not necessary this year, but yeah, it's like that. Yeah, so so I think I see your email from 8:49 p.m. I'll add you to Piazza. Yeah. Yeah. So the recording, I think. So I think it should be like literally the same link. It's going to convert from a live stream to a recording. Good night. Thank you. Yeah. Okay. Thanks. Bye, everyone. No one's typing, so it's a good time to stop the stream. Okay. I'll see you. Bye.